Okay, so today we're going to be talking about point-slope form. Point-slope form is another form of an equation of a line. We're used to seeing sloped-intercept form, which, as a reminder, slope-intercept form looks like y equals mx plus b. Okay, that's slope-intercept form. Today we're going to be talking about point-slope form, and point-slope form looks like y minus y1 equals m times x minus x1. And I'll keep referring to that formula throughout this. But the two things that are really important for us with point-slope form are, as the name suggests, we need a point and we need a slope. Okay, so those are two things that are crucial to today's content. So let's just jump right in. Looking at number 1 here on our notes page. Nope, I have some left over from yesterday, so let me just erase that. Okay, so like I said before, whenever we're writing point-slope form, I need two things. I need a slope and I need a point, because it's point-slope form. Now, the letter we've been using to represent slope is the letter M. Okay, so I'm going to write m equals -3. And then whenever I see a point, I really should start getting in the habit of labeling. So x1 and y1. That just helps me keep it straight, which are my x and which are my y values. Once I have my slope and my point, I'm ready to now plug them into my formula, which is reminded up here. But I'm going to copy it down just because I'm doing this for the first time. So I copy down my formula. And now it's time for me to plug some values in. So we said that slope was -3, or m was -3. So we're going to take this -3, we're going to plug it in for m. So I have a -3 where m is. And then I have some values here given for a point, and it was important that I included my little sub numbers ones, because this tells me this -1 is going in for this x1 right here. So I'm going to plug that one in there, and I'm going to plug a 7 in for my y1. And then I'm going to bring the rest down. I'm going to bring everything down. My parentheses, my symbols, my x and my y. And now look at my formula here. I'm almost done. The last thing that I should draw your attention is right here. I have a minus, a negative. When I see a minus, a negative, we know that that becomes a plus. Okay? So here is my final equation written in point-slope form. Let's do number 2. Again, I'm given two pieces of information that I need. I'm given my slope, m equals 2/5, and I'm given a point, and I'm labeling it x1, y1. Once I've identified the two things that are crucial, I'm going to plug them into my formula. A common mistake here, so here, let me plug in my slope. Again, slope goes in where that m value is. Now, a common mistake that I see a lot of students make is they take this 10 and they'll plug it in for this x. Okay, however, my 10 is representing x sub 1, which means my 10 needs to go in for my second x here. So I'm going to plug a 10 in, and then I'm going to plug in -8 in for my y. Bring the rest of my formula down, including my signs and my parentheses. Again, I'm almost done here. Everything's where they need to be. However, I see a minus, a negative. When I see minus a negative, I know that that becomes a plus. So I have y plus 8 equals 2/5, and then in parentheses, x minus 10. All right, I want you to try number 4 here. So identify your slope, and identify and label your points, and then go ahead and plug it in. When you're done, your answer should be y plus 3 equals -2, x minus 3, if you did that correctly. Okay, let's look at now. I'm giving you the equation, and I'm asking you to graph it. Okay? So, I guess I should go back here. Again, when we're talking about point-slope form, we're given two things, a slope and a point. Now, last section, we used to get y by itself, But that's a lot of steps, and if I can avoid that, I will. So when I see an equation like this and I'm asked to graph, the first thing I'm going to do is I'm going to check to see if it's in point-slope form. So if I look at this equation, is it in point-slope form? Well, I see yes it is. I have y minus a number equals a number and then a set of parentheses with my x coming first. So yes, this is in point-slope form, which means I can move forward. Now, when it comes time to graph, we're going to identify the two important things that I keep talking about, a point and a slope. So when I look at my equation here, and we think about my formula from before, so I'm going to write it off to this above, actually. Y minus y1 equals m times x minus x1. These values right here were the values of my point. So my 4 and my 3 are going to be the values of my point. 3 being my x, 4 being my y, because I'm following my formula. And then last but not least, I have a slope here of 2. Okay? Once I have this information, once I pull this from my equation, I'm ready to graph. I always start with the point that I'm given. So I'm going to find 3, 4. I'm going to go over 3, 1, 2, 3, up 4, 1, 2, 3, 4. Plot a point. Okay? And then I'm going to use my slope of 2 over 1. Now again, remember, if I have a whole number, it's technically over a 1. And I'm doing rise over run. So I'm going to go up 2, 1, 2, over 1, over 1. Plot a point. Okay, so that's the 1. I'll go the other direction too, so I have a point there. And then I'm ready to connect them. Okay, there's my line. Let's do another one. Come over to 6. So my first step was always to check to see if I am in point-slope form. Look at this. I compare it to my formula. Yes, we are in point-slope form. So I'm going to move forward. I'm going to find a point and a slope. Two most important things I can gather from this equation. So again, I think back to my formula. I had y minus y1 equals m times x minus x1. These two numbers right here were my point values. So when I look in my equation, I have a 5 and a 2 there. So I'm going to come down over here. My x value of my point was the 2. My y was the 5. And then I have my slope, or my m value. So in this situation, it's 1/2. Once I have these two pieces of information, I'm ready to graph. So I'm going to start with my point of 2, 5. I'm going to come over here on my graph, go over 2, up 5, plot a point. And now I have a slope of 1 over 2, rise over run. So I'm going to go up 1, over 2, plot a point. And I'll go the other way, down 1 over 2, plot a point. And connect them. All right. On to our next example. This one looks similar, but it's slightly different. So first, again, I need to check to make sure that this is in point-slope form before I move forward. I look at it, compare it to my formula. Yes, it is point-slope form. So I know that I'm using, like I said, that formula. I'm ready to compare because I need to find the two most important pieces of this equation, my point and my slope. Now we have to be careful. So let's look at for my point values first. We've been talking a lot about how these numbers matter to me, but I'm going to highlight this plus sign for a second, and you'll see why in a minute. Compare this formula to what I see here. Notice that my minus becomes a plus. Okay, again, my minus becomes a plus. Well, we know that if I were to rewrite this, x minus a -2 would become a plus. So in other words, if I were to go back, my x value is actually a -2. Okay, it's actually a -2. So when I come down here to write my point, I have a -2, 5. And what is a nice trick to remember that is, if you see a plus value in your formula, you know it has to be negative. If you see a minus sign, you know it has to be positive. So it's the opposite. See a plus, my point is a negative. See a minus, my point is a positive. Okay? And last but not least, we have our slope of -2/3. Now I'm ready to graph. I have my two important pieces of information. I'm going to come over my graph, go over to -2 up 5, plot a point. And now I'm going to use my slope to go down 2 over 3, plotting a point. I'll do it one more time. Down 2 over 3, plot a point. And I can connect my dots. Ooh, I didn't really connect those very well. And there's my line. All right. Now I'm giving you a graph of a line, and I'm asking you to write an equation. Now, we're all used to writing our equation where we find our y-intercepts, and then we count up, and we find our slope. However, notice my directions. My directions are asking me to write it in point-slope form. So that way it will not be helpful for me. In fact, I need to do it by first identifying my two important things. So I know I sound very redundant right now, but I need to find a point and a slope. Point and a slope. So it doesn't really matter. We're going to pick one. Okay, so I'm going to choose, let's see, okay, in the blue. We'll choose this one right here. Okay, so let's choose this one. Oh, actually, I'm wrong. Look, my directions even tell me what to choose. It tells me to use this point. So that part's already done for me. So I'm going to use that point right there. And now I need to find slope. Now, how can I find slope right here? I'm given a graph. How could I figure out slope? Well, I know that in front of me, I can go from this point to that point and count rise over run. So let's do that. So starting here, I go up 1, 2, 3, 4, 5, 6, 7. So I'm going up 7 over 1, 2, 3, over 3. Okay, so there's my slope. Now that I have these two pieces of information, I'm ready to write my equation. So I'm going to label x1, y1 here, keep myself in order. And I'm going to do y minus y1, which is a 4, equals, and here I guess I should keep my colors the same, equals my slope, which is 7/3, and then x minus 1. So there's my point slope form. So that's all I need to do for this one, so I'm done. Let's look at the next one. Now it's telling me to use this point. So point is now going to be -2, -3. And let's think about slope for a second. Is this slope going to change? No, it's not going to change because it's the same line. So I'm going to use the same slope, 7 over 3. And we're ready to plug it in. So I have y minus y1, which is a -3, equals my slope, which is 7/3, x minus my x1 value, which is a -2. And now I see all these minus and negatives, so I'm going to go in through and I'm going to make those into a plus. And now what I want you to do is I want you to compare this equation and that equation. My slope is the same. However, my two numbers here are very different. However, they represent the same line. So I've got two different equations that represent the same line. I'm kind of puzzled because I thought we should have the same equation. Let's come down here to part C, and we're going to rewrite the equations in slope-intercept form. I referenced slope-intercept form at the very beginning of our lesson today. We remind ourselves slope-intercept form is y equals mx plus b form. So in other words, I'm going to take these two equations above, and I'm going to get y by itself. So let's do one at a time. Let's start with A. So I'm going to come down here. I'm going to do A equation. A's equation was y minus 4 equals 7/3 x minus 1. And then I'll copy down B's while I'm here. If B was y plus 3 equals 7/3 x plus 2. Okay, so I have my 2-point slope equations. My job is to get them into slope-intercept form. In other words, I'm getting y by itself. So when I look at this problem, again, my goal is to isolate my y. And I see a set of parentheses. The first thing that I do whenever I see a set of parentheses is I want to distribute. So I'm going to go here and I'm going to distribute this 7/3 to both things inside my set of parentheses. So I'm left with y minus 4 on this side equals 7/3 x minus 7/3. Okay, now use a calculator. No reason to do all this in your head. At this point, again, I'm still trying to get y by itself. So I need to move the 4 to the other side, and I do it by doing the opposite operation. Oh, I don't want a highlighter. So I'm going to add 4 to both sides. So I'm left with y equals 7/3 x. And then I'm just going to punch this in my calculator as I see it. Whenever I punch that in, I'm going to get a plus 5/3. So y is by itself. I see y equals my slope, my mx plus b. So 5/3 is my y-intercept. Let's look at my equation for b, and let's do the same thing. So my first step, let's distribute my 7x, or my 7/3. So I have y plus 3 equals 7/3 x plus, and then 2 times 7/3 gives me 14/3. Now my goal is still the same. I'm trying to get y by itself. So I'm going to subtract 3 from both sides. Now notice that I'm subtracting 3 from my fraction and not from this. Do you know why? It's because this has an x with it. Okay, I can't subtract two things that don't share a variable. So I have to subtract my 3 from my constant. Once I do that, my y is by itself. I'm left with 7/3 x plus 5/3. So once I get y by itself, if I compare my equations again, I'm left with the same equation, which is good. So what does this mean? This means that I can use any point on the line to write an equation. Even if it looks different in point slope form, it's still the same equation, which is what we showed down here. So let's look at 9. Now I'm asking you to write the equation of the line in point slope form first and then slope intercept. So the reason we do point slope form is because we love it. Point slope form is very helpful. So let's start there. So I remember point slope form is y minus y1 equals m times x minus x1. The two things that I need here are a point and a slope. So let's look at my graph. And like we demonstrated before, it doesn't matter what point I pick. So let's just pick one. I'm going to choose this one. Okay, so I'm choosing that point right there. That point is located at 3, -1. So let's come over here and write 3, -1 for my point. And then my slope we talked about earlier. The slope is found from my rise over run from this point to that point, okay? So I'm going to go down this time, so I know it's a negative. So I'm going down 1, 2, 3, 4, 5. And then I'm going over 1, 2, 3, 4, 5, over 5. So I have -5 over 5. That simplifies to a -1. Once I find those values, it's time to plug them in. So I have y minus, my y1 value is a -1, equals my slope value is a -1, and I have x minus my y1 value, which is a 3. Again, I see a minus and negative, so I'm just going to make it a plus. And there's my point slope form right here. Now, the next part, slope intercept, let's just practice what we did in the previous section. And let's just use my point slope form and get y by itself. So I'm going to copy this down. So I have y plus 1 equals -1 x minus 3 here. And I'm going to get y by itself. So I'm going to start by distributing my -1 to both things. So I have y plus 1 equals -x plus 3. And now my last step is to subtract 1 from both sides, only subtracting it from my constant. So I have y equals -x plus 2. Now, let's compare this. So here's my equation in points in slope-intercept form. Let's look at my graph. We know how to write an equation from a graph as well. I always start with my y-intercept. So my y-intercept is a positive 2. And then to go from here to the next point, or here to even here, I go down 1 over 1, which means my slope is a -1. I write in the rest of my information, and now let's compare. It's the same. Okay, I have a -1. There's technically a hidden invisible 1 right there. So I get the same equation. So now you know 2 ways of doing this. All right, flip over. This is what we've been building up to this whole time. We've been building up to this point. Our job now is going to be to write an equation in slope-intercept form of a line that passes through these 2 points. Okay? So I give you 2 points. Remember, what do we need to write in point-slope form? We need a point, and we need a slope. Doesn't really matter which one I pick, so let's just pick one. I'm going to choose the first one, because then I'll avoid more negatives. And now I'm not given a slope anymore, and I also don't have a graph. How did we find slope? Well, we use my y2 minus y1 over x2 minus x1. So let's do that. Okay, here's my x1, y1. Here's my x2, y2. So I'm going to plug these numbers in, -1 minus a -5 over -2 minus a 3. This becomes a plus, so I'm left with 4 over -5. Now, that negative I know can be interchangeable. I can move it up or down. So I'm going to say that my slope over here is -4/5. Okay, -4/5. Now that I have my point and my slope, I'm ready to plug it in. So I have y minus, let me keep my colors the same like I've been doing. Y minus my y1 value equals my slope, -4/5, times, in parentheses, x minus my x1 value, which was 3. So there's my point slope form. Again, I'm going to make this into a plus. So there's my point slope form. Next step here is to get in slope-intercept form, or y equals mx plus b. So in other words, I need to get y by itself. Okay, so I'm going to copy my problem down. Okay, I'm going to distribute. So I get y plus 5 equals -4/5 x. And now this is a hard thing to distribute. If we distribute these, -4/5 times 3, you should get a 12/5. And it's a positive. Now from here, my last step is to subtract 5 from both sides. So I'm left with y equals -4/5 x. And then 12/5 minus 5 gives me -13/5. There's my answer. Okay, I want you to try 11. Pause my video. When you're done, your slope at some point, make sure you got that step correct, should be -1/3. And then regardless of what point you picked at the very end, your answer should be y equals -1/3 x plus 11/3. Look at 12. So if we look at 12 here, now I'm giving it to you in a chart. Okay, so in a chart, I'm given a bunch of hidden little points. These are all points, okay? So when it comes time to pick the two important pieces of information here, a point and a slope, I'm just going to choose a line of my chart. So I'm going to pick this first one. That's going to be my point. So I'm going to have 10, 640. Oh, geez. I don't know what happened there. Little brain glitch. There we go. Okay. And now slope. Slope is change in y over change in x. So let's find my change in y. My change in y from my first row to the second row is a negative 50. And then over my x, I'm adding 20. So if I were to write this over my slope, I'd have a negative 50 over 20, which simplifies to negative 5/2. From here, I'm ready to plug it into my equation. So I have y minus y1 equals m times x minus x1. So I have y minus, my y1 value was 640 equals, my slope was negative 5/2, x minus 10. And now let's go back into my problem and see if I'm okay to leave it in point slope form. It says what equation in slope intercept form? All right, so slope intercept form. So I need to get this as y by itself. So I'm going to distribute my slope. So I'll come up here. So I have y minus 640 equals negative 5/2 x. And then once I multiply that with my 10, I get a plus 25. Now I'm going to add 640 to both sides. So I'm left with y equals negative 5/2 x. And then 25 plus 640 is positive 665. And it's asking us what these numbers means in terms of my problem. So if we look at my slope, it's my change in y over change in my x. In other words, my change in altitude over my change in time. So I would say here that for every 2 seconds, the hot air balloon is descending, because it's a minus, descending 5 meters. And then my y-intercept, that's always my starting place. So this is the height of the hot air balloon at the very beginning. All right, I want you to try 13 and pause my video. You should have had a slope that was 1,250 over 1, or you could have just written 1,250. My point slope form was y minus, and I used the first point. I used this one right here. So that should have been your point slope point slope form. And then my directions actually say I can stop there. Okay, so I don't need to go any further. If you did, not a problem. Your last equation should look like this.